So lads, what we're doing is what's called, you might have an XY axis, okay, as an example in these questions. Now, what will happen is you will have just say a square. This square is of length 4 in any given direction, okay? Now, what happens is you can undergo what's called a scale factor K. The scale factor will make the new drawn, if I say a scale factor of 2, my new drawn is, the lengths are twice as large as the old drawn. So for example, it'll be 8 here, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4, and then you have every side is now double the length. Everybody happy with that?
Yeah.
Now, however, there's like a dimensional thing on here, and let me explain. When you do 1D, means 1D is length and width. When you multiply by a scale factor of 2, your one dimension is your lengths are affected by a factor of 2. 2 dimensions means area. The area of the first one is 16 squares, while the area of the second one is 64. What happened was it's gone up by a factor of 4. It's actually the K value squared. Do you understand that?
Yeah.
So your area, if your scale factor goes up by 3, your area will go up by 3 squared, which is 9 times. Okay. So you're in one-dimensional terms. Your length and your width, it goes up by a factor of K. 2 dimensions, it goes up by K squared. Now, if I was to turn these, guys, pay attention. If I was to turn these all into, cubes, yeah? Is everybody happy with this being a cube? Now, this is a 4 by 4 by 4 cube. Okay? What is the volume of this cube? If it's 4 by 4 by 4?
64.
64, okay? Now, I'm going to do the same thing with this one here. If I turn this one, so this is 1, 2, 3, 4, 5, 6, it's 8 that way, it's going to be that way, and then, so I have a cube on this one as well, okay? And as you can see, this one is now going to be, it's going to be 8 multiplied by 8 multiplied by 8. And what does that get me? 512. Okay, 512. Now guys, divide your 512 by 64 and you realise that it's 8 times as big this time. So 3D is 8 times as big. 8 is equal to K cubed. So long story short, when your scale factor is K, the volume increases by K cubed. When your scale factor is K, the area increases by K squared, and your lengths increase by whatever K is. Alright? Now, another thing they might ask you is, we'll just go back to our 2 squares at the very beginning. Okay? So what they might ask you is what's called the centre of an enlargement. Okay? To do a centre of an enlargement, oh wait, need that back there. So to do a centre of enlargement is you go back to the original side. See that you pair up the sides and you continue your line through. You get this one here and you match it to the bottom left one. You get the bottom right one, match it to the other bottom right one, and then finally get the top one, match it to that one there. And you can see it's like a projector screen. You can track back to where the centre of enlargement actually is. That makes sense? Okay, let's start off with a question or two. Okay, the triangle YZ is the image of the triangle ABC under the enlargement at centre row. So guys, what this basically means is like the projector screen we said earlier. Each side goes through its corresponding points, okay, to make the other triangle. Frank. Now, first thing it goes is find XY. Well, what we can say here is it says enlargement of 1.5. Multiply 4 by 1.5 and we get 6. Divide 12 by 1.5. I think it's 8. So that one's going to be 8. Are we happy with that? AC is 8, XY is 6. If the area of the triangle ABC is 12.2, calculate the area of the triangle XYZ. So ABC is 12.2. What did I say about area? It's two-dimensional, which means it goes up a factor of 1.5 squared. It's 1.5 squared, and what did you say it was? 27.45. Is a centimetres just units squared, because we don't know if they're centimetres or metres. Okay? You happy enough with that one? Start off with. Now, question 4. Write down the coordinates of A, B, and C. Okay? I'm not going to get too taxed by that. 2, 1 for A. B is 5, 1, and C 5, 5. Okay. Triangle PQR is the image of the triangle ABC by a scale factor of 3 from the center of enlargement. Scale factor of 3. Okay. Using rays or otherwise, find the coordinates of P, Q, and R. So what I need to do is this length here, which was 4, it now has to be what size?
12.
Has to be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? Now what I can do is this. Just going to drag this 12. See the way I'm dragging it along the bottom one?
Yeah.
And then eventually I'm going to hit. And that's where I can fit it in.
Nice.
Okay? 12 up there. And then this is a... what was that?
3.
That was 3. So that's going to turn into...
9.
4, 5, 6, 7, 8, 9. Okay? And that has to join to the bottom corner. Oh.
Oh, yeah. There.
Alright, and finally the last one will be just simply just join them together. There's your enlargement there, okay? Now, calculate AC. It says enlargement of 3, right? So what I'm going to do is do Pythagoras' theorem. 3, 4, Pythagoras' theorem to get that is 5. Enlargement of 3, so it says PQR, so it has to be in the same order. So that's P, Q, R. Do you see how I matched up the letters?
Yeah.
A is basically P, Q is B, C is R. Then you have multiply everything by 3, so you're going to get 9, 12 and 15. Okay, calculate AC, done. Calculate PR, done. Calculate the ratio of AC to PR. AC to PR is 1 is to 3 because it's a scale factor of 3. Calculate the ratio of the area of PQR to the area of ABC. What do we say about the scale factor is 3, so how much bigger is the big triangle than the small triangle in area terms?
9.
3 squared, which is 9. Ratio of 1 is to 9. Happy enough with that. Now, we have next is Kenny painted 2 similar rooms with the same paint. One tin of paint can cover roughly 10 meters squared. The smaller the 2 rooms needed exactly 2 tins of paint. Each length in the larger room is 1.5 times larger than the corresponding length in the smaller room. How many tins of paint did Kenny need to paint the larger room? Okay, just give me 1 second with this. Alright, the smaller room, I'm just going to treat the full room just as a box because it'll just be easier for me to visualize. Okay, so it says he needs 2 tins of paint. That makes that 20 meters squared. Okay, then if you're painting something, it's an area, not a volume, it's an area. Paint covers area. Okay, so therefore he said that the larger room is 1.5 times larger, but the area is going to be 1.5 squared larger. Yes?
You already had to do that before you got the meter square.
Sorry? You have to multiply the new size. No, I only have the size of the small room. I need to put the size of the larger room.
You have that in 20 meters squared.
Yeah.
You still have to multiply the 1.5 squared.
Yeah.
Okay.
And so 20 times 1.5 squared? 45. Now, 45. I can show you a simpler way. This is just the way my brain works, so I have to map it out visually and pretend I'm actually doing the paint job, okay? Now, the small room needs 2 tins of paint. We know that each tin of paint covers 10, So divide that by 10, you get 4.5 tins of paint, but you're going to have to buy 5, right?
Yeah.
Now, what you could have done potentially was, you could just get your 2 tins of paint and multiply the answer by 1.5 squared, and you can get 4.5 straight away. I would personally work it out that way.
Yeah, I agree with you, but otherwise you're just taking stuff out.
Yeah, I like to explain it properly as if I was doing the job myself. Now, number 9.
Many painting jobs.
Phase A and phase B are similar. Similar means they are every angle, every size is in proportion, not the same size. Congruent would mean same in every way. Once again, surface area, locking it down to the 2D case. Surface area is 60, this one's 375. Therefore, what we're going to do is going to figure out k squared. K squared is 375 divided by 60. The area is divided by each other. So 375 divided by 60, and you get 6.25. Square root that, and you should get k equals 2.5. Now, if the scale factor is 2.5, length is linear, one-dimensional. So multiply 8 by 2.5, and what do we get? 20. The height of the bigger phase is 20 centimeters. Is that right? Okay. Now, question 12. Okay. The enlargement read on the photocopier is 100% when the copy is to be the same size as the original. When the reading is 110%, each length is increased by 10%. So the way I'd read that is, if I had a original that was, I don't know, 20 centimeters by 10 centimeters. If I take our original image that's 20 by 10, if I go 110%, that should turn into 22 and 11. Add 10% onto either side. Now, it will, however, cause a jump of an area of 200 to an area of 220. Okay, so although I increased my lengths by 10%, how much did I increase my area by? Increase of 20 divided by 200, still an increase of 10%. Okay, so that's an interesting one. We'll try 20% just to see if this still works out. If I increase them by 20%, what happens? Yes, Harry?
Is the area the 11 by the 22?
The 10 by the 20 for the first one. Oh, that's 11 by 22.
242.
Sorry?
242.
Oh, sorry guys, my fault. 242. Yeah, I was wondering if something was wrong there. So 242 is a increase of 42. Okay? 42 divided by your original 200 is what percentage increase?
21.
So, what? 21%, right? So, let me show you what's going on here, guys. Okay? So, what enlargement reading would you use if you want each length to be decreased by 30 degrees? Each length decreased by 30? Question 12, 70%. 0.7 of what it was. Okay? 8 centimeter line increased to a 12 centimeter line. 8 divided by 12, or 12 divided by 8. 1.5. What's 1.5 in percentage terms? 150. 1.5 times larger than the original. A 15 reduced down to a 9. 15 divided by 9. Or is it 9 divided by 15? Sorry, it's 9 divided by 15. It has to be, if you're reducing it, it has to be a number smaller than 1. So 9 divided by 15. What'd you say? 0.6. 60%. Okay. A shaded area on the original is 50 centimeters squared. What is the shaded area on the copy when the enlargement reading is 120?
So just 50 by 1.2 square.
Okay, just give me 1 second with this one. I'm going to multiply by 1.2 squared, you reckon?
Yeah.
Let's try that out. 50 multiplied by 1.2 squared Get you 72, that's perfect, okay? So guys, the scale factor is, when it's 120, the scale factor is 1.2. Therefore, k squared is, you multiply your 50 centimeters by k squared. 50 times 1.2 squared is, anybody?
72.
50 times 1.2 squared equals 72. So that's going to be 72. When it's 60, it's going to be 50 multiplied by 0.6 squared. 0.6 squared, anybody? So 50 multiplied by 0.6 squared. Sorry about that. 18. Okay. You good? Shh. Okay. Shh. The ratio 120 is to 60 is equal to 2 is to 1. Explain why the answers in part 2 are not in the ratio 2 is to 1. Okay. Any reason why? The reason being is its area and it's affected by a value of the enlargement squared. Everybody got that? Enlargement squared. What percentage correct to the nearest whole number would you use on the photocopier to double the size of a document? Justify your answer. Now, to double the size of your document. Now, you would think 200, okay? But what they're going for is 1.41. Now, let me explain where they get that from. Okay. When you want to double the size of a document, right? What they're thinking of is the area. If you wanted to double the length of each side, it'd be 200%. But we know that when you double the length of each side, you're actually increasing the area 4 times. So what you need to do is you need to say k squared, whatever your scale factor is, gives you twice your original area. Therefore 2 is going to be the square root of 2. Square root of 2 is 4.14 around the 2 decimal places. Multiply that, put that in percentage terms, you're going to be 141% larger than usual. Is that alright? Now finally, to exactly double the size of a document, the scale factor of larger than root k, what is the value of k? Justify your answer in conjunction with part 1, okay? Your k value is basically what we went already. We're doubling the area, we're not doubling the lengths. So to double the area, we need k squared to be equal to 2. Therefore root k equals root 2. Sorry, k equals 2. Okay? No, 2. Oh, sorry, that's k, not root k. By square root of the square.
Right.
Okay, equals root 2.
Right, that's her, man.
No, wait. To exactly double the scale factor of enlargement is root k. What does the value of k need to be? Oh, sorry. Give me a second. There's always one. Sorry. The answer back to the book is k equals 2, and let me explain why. Okay. To exactly double the size of the document, if I had an area of 20, they want the next one to be 40. They want your k squared to be equal to 2. Therefore, the scale factor, I'm going to use a different letter for this because having k too much is confusing us here, right? I'm just going to call it s for scale factor. Scale factor squared equals 2. Scale factor therefore equals root 2. But they said the scale factor is root k. Hence k equals 2. But using the same letter twice, it confuses you. That's where they're trying to get you with that. Okay? Now, last one I think. Alright, there is a 17.
So you want us to do the trapezoidal one?
Which one's that?
Yeah, 16.
Okay. Now, okay, draw the enlargement of shape A with a scale factor of 1/3 and a center enlargement. So guys, what happens is I'm going to draw, let me see, scale factor of 1/3. Okay, here's what we're going to do. I got it. This is 3. This one here is 6. A scale factor of 1/3 would indicate that you are reducing. Scale factor means you're actually drawing a smaller object.
It says enlargement.
Oh yeah, sorry, enlargement is a loose term. If k equals 3, you're increasing the length of each one by 3. They can say an enlargement of k equals 1/3, and if that's
3 times 1
that's basically you're decreasing each length by a factor of 3. So anytime it's a fraction, you decrease by a factor of that. Okay. So this one was 6. Now I'm going to have it down as 2. Okay. This one was 3, which now makes it 1. This one was 3. It's going to be 1, and then join it up, and there's its smaller part there. Now, calculate the area. Well, the area is easy to do because we must do a half base by height here quite easily. So that's 3 by 3, which is 9. The other one is a half 3 by 3, half base by height, which is 4.5. So the original was 13.5. Divide 13.5, or sorry, multiply by the scale factor squared. So it's going to be 9 times smaller, but 1/3 squared. That's going to give me 1.5. You can see it there, half a square plus a full square. So shape A, shape B, done. Verify that the ratio of the area of shape B to the area of shape A is k squared. Okay, I'm just going to get 13 point. Well, they'd actually want me to calculate this properly. 1 by 1 gives me 1. A half 1 by 1. They just want me to calculate that's 1.5.
Yeah.
Then they want me to get the new area divided by the old area is equal to 1/9. 1/9 equals k squared. K equals 1/3.